So a little more difficult concept here. So 1 to 2 reaction, and we did this one last time. Methane CH4 plus 2 parts oxygen gas O2, turning into carbon dioxide and 2 parts water. Okay, and your masses are up here again. So this time again, I give you 4 grams of methane and 14 grams of oxygen gas. And before you go any further, you have to say, wait a minute, this is not like what we did the first time where I just was given the amount of one starting material and say, okay, how much stuff can you make? And how much of the other starting material do you need to react with, with it? You need to figure out which one might be holding you back. And then you also need to recognize and saying, wait a minute, for every 1 molecule of methane that disappears, 2 of oxygen disappears. So you're going to need twice as much of this as you will this, and that's going to change the game. So 4 grams of methane, but it has a molecular mass of 16 grams, I've got 0.25 moles. I've got 14 grams of oxygen, it has a mass of 32 grams, so I've got 0.44 moles of oxygen gas. It's a 1 to 2 reaction. So I stop a minute and I say, wait. My brain's lazy. It's a lot easier if I can think about the thing that's in 1 and I say, wait a minute. I've got 0.25 moles of this. If I double it, that's 0.5. It's a half a mole. Let's compare. I've got 0.44 moles in reality. Well, if it was exact 0.2 to 0.5, we'd run out of both at the exact same time. If I had 0.6 moles, I'd have some left over. But wait a minute, I've got 0.44. So what that's telling me is if I was 0.2 to 0.5, I would run out exactly. Oh, but I've got less than that theoretical perfect amount. I'm going to run out of my oxygen first. So I like starting with the reactant that's my 1, and then I look at the other thing and I say, okay, well that's 2. So let me double it. And if I've got more moles than what I doubled it to, I know I'm going to run out of my thing that's in 1. Oh, but in this case, I doubled it and I have less than that theoretical amount. I'm going to run out of that. Oh, okay, so when I do my rice table, let me just do one more thing. I've actually got 0.44 moles of my oxygen. If I divide that by 2, that's 0.22. So that's how much methane is going to disappear and how much carbon dioxide is going to appear. Because 0.44, oh, it's only going to pull out half of that methane. So I'm going to have some methane left over when this is all said and done. Let's see how that looks with the rice table, and then we'll do it with the math. So switch out this dry erase board onto the new one. Again, this is just like the s'mores. In this case, the oxygen is like the graham cracker when my family punked me out, and the methane's like the piece of chocolate. Ran out of that first. The oxygen is the stuff that's going to be left over. Okay, so here's what we got. Just like what we were doing before. So this is what I actually have, 0.25 and 0.44, 0 and 0. Haven't made anything yet, don't have any products. Okay, so I'm going to run out of my oxygen, and half of 0.44 is 0.22. Oh, well, that's going to be how much carbon dioxide I'm going to make. And then 2 to 2, well, that's going to be how much water I'm going to make in moles. Cool. So when this is all done, I'm out of oxygen. I'm going to have just a little bit of methane left over. Oh, okay, cool. Well, let's do this again. How much carbon dioxide am I actually going to have? Well, I know how many moles I have, 0.22 mole, and it weighs 44 grams per mole. So when that's all said and done, it's 9.68 grams. Okay, well, what about water? Well, I've got 0.44 moles, and it's 18 grams per mole. Well, 0.44 times 18, 7.92 grams. Okay, that's not so bad. That's doable. Yeah, and even if this were 1 to 3 or 1 to 4, all these ratios would make sense. You've got a 1 to, you've got a 1 to kind of normalize or compare yourself against. All right, well, let's see the math method. Flip it around. I'd like to bring my bird out, guys, but she has been just keyed up lately. Okay, so when you're making water, and again, your answers are probably going to be just a little bit different because you're not rounding off here when you're doing things this way. You can just put it all in your calculator and carry answers. So 14 grams of oxygen. So first step, convert grams of oxygen to moles. Oh, 1 mole of oxygen gas weighs 32 grams. In your balanced chemical equation then, 2 moles of oxygen turned into 2 moles of water. That was your 2 to 2 step, okay? Same amount of pieces. Well, then 1 mole of water has a mass of 18 grams. When you punch that into your calculator, that came out to 7.88 grams. That's really close to what we had the other method. Feeling pretty good about that. I like it. For carbon dioxide, first step's still the same. 14 grams of oxygen, use your molecular mass to convert. Second step, 2 moles of oxygen turn into only 1 mole of carbon dioxide. So we're going down in terms of total molecules. We're cutting it in half. Last step is still a molecular mass conversion. 44 grams of carbon dioxide is 1 mole. So 14 times 44 divided by 32 times 2. Oh, when you put all that in there, that's 9.63 grams. Those two answers that we did from the two different methods both come out really close. Really like that. So we've done this now 3 times. Once with our s'mores example, once with a 1-to-1 actual chemical reaction, and now once with a 1-to-2 reaction. I'm going to show you a more complicated reaction that I will solve through. And I want to convince you that when things start to get complicated with your chemical equation, that you don't have to do it with the math method, but that maybe you want to. Okay? Last one coming up.